Hi, this is a short little video to kind of share with you some of the division strategies we're working on this year. Our goal, especially at the beginning of the year right now, is that they have one strategy and by the end of the year they have a couple of different strategies that they can use to help with division. The first one, I guess, is what we're starting with is similar to what we did with multiplication. That's kind of a break apart strategy to make it more visual. So they use what they know of multiplication to get to our answer here. So for example, I have 102 divided by 4. And so one thing we've been working on is kind of just really, literally making 4 boxes or 4 groups and seeing, well, 4 times what can get me to 102. And they might start simple and say, well, I know I can give everyone at least 10. Okay, so they would show 4 times 10 is equal to 40. So they would take 40 away, and they'll be left with 62. Then they know, well, I can give everyone 10 more, which is another 40. So we would subtract that away, and now we're left with 22. And hopefully when they get to this number, they can start using, their basic facts of, 4, 8, 12, they can skip count to it, or know that 4 times 5 is 20, which is the closest I can get. So I can give everyone 5 more, which is 20. So if I subtract 20 away, I'm left with 2. So my answer is 25. Everyone gets 25 with 2 left over. Right now, we're hoping though that as they get better at multiplication and as we do more with multiplying by tens, they can start with a larger number. So they might start right away, hopefully with knowing, well, I know 4 times 10 is 40, 4 times 20 is 80, 4 times 30 is 120. That would be too many. So I can get everyone right off the bat 20. So they're starting to work with larger numbers. But again, the nice thing about this flexible strategy is they can start with small numbers and progress their way up. But if you start with 40, start with 20, you can get there a little bit sooner. So they would take 80 away right away, and we're left with 22. And then here we have 4 times 5 is 20. Take the 20 away, left with 2. And you still end up with the same answer of 25 with the remainder of 2. Okay, so that's kind of one strategy, to kind of break it apart and do it in parts and put those parts together, similar to what we were doing with multiplication. Another strategy, it's called Super 7, and we kind of turn this into a big giant 7. And how this works is they show how many groups are taken away on the side, and then they subtract those groups throughout. So for example, you can ask yourself, okay, how many times can 7 go into 92? And well, again, I can give at least 10. So over here, I'm giving 10 groups. So, for example, it's really 10 times 6. I'm sorry, 10 times 7. I can give these 7 people each 10, so that's a total of 70. So right here I'll show what I'm taking away, and I'm left with 22. Right, well, how many groups of 7 can I get out? 22, 7, 14, 21. I can get 3, so I can get 3 groups of 7, which is 21. If I subtract that, I'm left with just 1. So here I have my answer of 13 with a remainder of 1. Okay, so they can do this by showing their actual groups, or they can do it where they just show the groups. So I'm going to give, let's say I'm going to start with 10 again. 10 times 7 is 70, 22, and 3 times 7 is 21. 1 left over. My answer is 13 with a remainder of 1. And this strategy works really well for students that don't know their large digit multiplication yet, and you can kind of use this to kind of add some different, I guess, go in different parts. So let me do it with a larger number. All right, my super 7, let's go 236, I don't know, divided by, let's say 5. Okay, so I know I could start with 10. 5 times 10 is 50. Well, 5 times 20 is 100, so maybe I'll start with that. So 5 groups of 20 is 100, and I'm left with 136. Well, I could do that again. Give everyone another 20. 20 times 5 is another 100. Left with 36. I know 5 times 7 is 35. So 5 times 7 is 35. I have 1 left over. 47, remainder of 1. Okay, and again, this is nice because they could start with smaller groups. Now, our goal is that they eventually start to realize, well, what's the closest I can get? Because the closer you can get means you're doing less subtraction. And we find, obviously, the more subtraction you're doing, the more chances of errors. So our goal is, as we start to get into larger digits and we start doing more of the multiplying by tens, they think, okay, well, let's think of this as kind of 23. 23, well, 5 can go into 23 4 times. I know 4 times 5 is 20, but I actually want 200. So if I add a 0 here, I add a 0 here. Okay, so then they're kind of thinking more in larger digits. And so I know 40 times 5 is 200, because if 5 times 4 is 20, then this is what we're going to be working on this next week. I know 5 times 40 is going to be 200. So using these extended facts, we call them, okay, multiplying by tens and hundreds. And so then again, if you do it this way, then it really requires only 2 steps, because now I have just 36 left if I do a 40 right away. And I know 7 times 5 is 35. Okay. So there's really kind of 3 key strategies besides the traditional method, which we'll be doing as well. The first one again is, let's go back to our page here. Oops, sorry, too far. Breaking it apart visually and doing it in sections and subtracting throughout. So, kind of the goal is that they're subtracting throughout, so they keep track of how many they have left as they go through. Let me fill that one in, sorry. A second method is where they are multiplying the groups and putting it on the side and subtracting throughout. And then, I guess the super 7 I call it, or makes this giant 7, where they just start putting the groups because they're starting to realize, okay, this is 10 groups of 7 and 3 groups of 7. And we can do that again with larger numbers. So they could do it in small chunks, but our goal is that they eventually get as close as possible, which is similar to the traditional method. But the nice thing about this is it kind of shows representation of place value, because when you do traditional method, you kind of just you see the 2 as a 2 and the 3 as a 3, and you kind of work your way down. And then we teach them too, then obviously no matter what you do, you can check using multiplication. So I can do 47 times 5, and I'll use traditional method here. This is 35, 23, add the remainder back in, and I should finish with what I started with. That way I know I did the problem correctly. So between these different strategies, as well as the multiplication check step, they should have some nice success when they're dividing. If you have any questions, please don't hesitate to email your teacher. Thanks.